Okay, I'm just going to check the audio, and hopefully it'll make really weird noises. Oh, okay. So I've tested the audio. But they were conventional noises, but here's weird noises. Sorry. Okay, so I made those noises with Ruby driving propeller head reason in like 2005. And at the time I was very, very proud of it because the code uses continuations, which is why it's called Ruby continuations.mp3. But you may have noticed that it is not actually that musical, right? So let me see if I can wake up the various gadgets that make these sounds. So this is Reason, which is like prosumer software for making music. Okay. And this should... Oh, it's got all weird size. Hold on. Okay. This should make some music. Okay, so more musical than last time, right? And it changes the beat, which is kind of cool. But say we want to have like a more constant beat, right? We don't want it to change on us unexpectedly. So now it's a regular beat. It's very predictable. It's going to stay like this until we change it. And we can change it. And, you know, that's kind of cool, right? But actually, it's kind of repetitive, too. So it's kind of more fun to let the machine figure out what it wants to play for us, right? Because then we don't have to do anything, right? I can sit here and tell you about it while it makes up music. Although it does get a bit repetitive after a while, even with this. So this is a text output. Okay. Yeah. Okay. So right over here, let's see. Is that readable? Hold on. Okay. Okay. So that's right. That's Ruby code, right? Okay. This Ruby code is, you know, obviously saying that a MIDI object should play a note, create a note, and play it with particular parameters, right? And the last parameter in the play, right, is a float. That represents the time from the start, right? So when I started getting this really working the way I was happy with it, I told a friend of mine about this, and he was a techno DJ who had done experiments like this, and he said the number one thing you need to do is record it while you're doing it, because sooner or later your random number generator is going to come up with something really cool that you like the sound of. And because it's driven by a random number generator, you're never going to be able to get that sound out of it again. But the thing is, recording it is actually a tremendous pain in the ass, because audio... Don't do that, computer. Hold on. Let me chastise my beast. Okay. Audio, it takes up a lot of hard drive space, right? So if you simply dump a text log, you get something that you can replay. You know, you can generate hours of this just by, you know, having a log file of executable Ruby code, right? So any performance can generate, any performance is storable. Now, there's also this stuff here, which serves the usual function of debugging output and just tells you what's going on, because it's not finished. So this is Archaeopteryx, right? And that's not the only thing that Archaeopteryx can do. Archaeopteryx sends MIDI data, right, which is actually like a lingua franca for, the common language for every like synthesizer, every sampler, and every piece of music software, right? So this is a piece of music software called Ableton Live, right? And what you use this for is sample playback. And it's kind of the standard for DJing, right? People who DJ with laptops, this is mostly what they use in most cases. So there it is playing like, that's a complete song, right? These are loops. And you can see in that bar down at the bottom, that defines the loop, right? That tells you what section of the audio to play, to loop on. Okay. So these faders, because this is designed to be used in a live DJing environment, right? What they did is they took advantage of MIDI, right? Which gives you MIDI controllers for all sorts of music, right? All sorts of live performance. There's keyboards, guitars, saxophones. And they said, we can use this for DJ stuff. So there's DJ mixers where, you know, if you move like a fader, it'll send a MIDI message, right? So, hold on. If you go over here, you get this special interface which allows you to define MIDI messages. So I wrote some code which sends MIDI messages and takes control of this stuff. Let me. Okay. So that is called Doc Ock, named after Dr. Octopus. Because this version only has 4 channels, but one of the test versions had 8 channels. And it was like, you know, if Dr. Octopus was a DJ, what would he do with the faders, right? Because if you have programmatic control, you can do stuff much, much faster than a human DJ, right? And plus, you know, if you've ever been at a party and annoyed by a bad DJ, you know, it gives you a special feeling to realize that you can replace a bad DJ with a shell script. So here is some bad DJing. So hopefully it's obvious what's going on here, right? It's just sending these MIDI messages. They're in time, right? Up in the corner, that tap tempo button, it's right over here. You can use that to simply say, you know, my record is going at this beat, you know, I want you, Mr. Software, to play at the same beat, right? Which is what they expected people to do with it, right? Human DJs, right? They want to be able to just, and you got the beat, right? Great, right? But because it is also accessible by MIDI, it is accessible to Ruby, right? So we just send a MIDI message to the tap tempo, right? We use this to associate. Okay, this is impossible to see, but there are little digits by each of the controls which have been assigned a MIDI parameter, right? And you'll notice that there's a lot of blue controls, right? Every one of them could receive a MIDI parameter. Every one of them is susceptible to programmatic control. And there's a lot of them. And they do cool stuff. Anyway, you use that to drive the tempo, right? Which means that you can actually sync the fader movement to tempo, or additionally, you can also sync it to the drums. Now this This is relatively, experimental still, this part, but it usually works. So right now it's in this little squiggly bit, right? When it gets to the really dense bit, it's going to make a lot more noise, right? And that point is where the drums come in. So what you'll find is that the drums should come in either roughly or exactly on time. So you do a little building, right? You bring in more instruments. And it's more or less on time. Now, another neat thing that you can do with this, right? You can take this out, right? Kind of repetitive, so let's put it back on the generating. And by the way, I'm going to explain how all this, or at least most of it, works. Right. So not only does that give you the ability to, okay. Not only does that give you the ability to make the changes live in real time that you want to make, right? You can take out this track, bring in the other track, and the drums remain in sync, right? So if you want to remix a song, or if you want to have a drum machine playing any kind of samples, not just beats, right? That's very easy. It's all there. And of course, since, bringing out the one track and, lifting in the other track was done with the faders, that's also something you can automate. Now, normally, I do like this, very rehearsed presentation with like 100 slides. Actually, 600 slides, even. The first version was over 400 slides, and then I added more to explain the tech content. But I kind of just wanted to show you all the stuff as it was at this moment, and kind of get into the code, because it just seemed like the thing to do. So, just for perspective, the goal here is not actually to replace bad DJs with a shell script, right? Because although I could do that, it's very hard to sell to the DJ community, right? And people, there are a lot of bad DJs who are actually sort of hometown heroes and well loved. And however bad their DJing may be, sometimes they contribute something to the community by organizing parties. Other times, they just suck, right? So, the goal is, right, you create this tool and, people can use it. Like good DJs, bad DJs, anybody. But another bit of functionality that this tool has, right? You can actually just turn it on and leave it running, right? So that stuff where it was generating the beats, right? If you slow that down, right, it produces a different vibe, right? Like really fast music produces one feeling, right? Really slow music produces another, right? The way those drums were coming, right, is it was sending MIDI signals to a drum machine, which is actually just a sample playback device, right? So if you load, drum samples in the sample playback device and tell it, play these drum samples at a high speed, right, what you get is a drum pattern for fast dance music, right? If you load it with samples that are like the sound of crickets chirping and eagles, going, ah, and all that stuff, right, then what you get is ambient music, if it's playing back slow, right? And not this kind of ambient music that is like weird and dissonant and frightens people, right? This is this is technically ambient music and works on the level of being like abstract and interesting to listen to. But, there are circumstances, some people like to listen to ambient music under the influence of psychedelics, right? If they were to listen to this music under the influence of psychedelics, I don't think the psychological consequences would be positive, right? So if you load different samples in and you play them back slower, you can produce psychological effects that are not negative, which is a good thing. Okay, so let's see. Here's basically how it works, right? Okay, so this file that I was editing is called db drum definition, but the command line, the file I was running, was called eval style. So basically, this here, the rhythm, this is very poorly organized code, by the way, just now. It's been just, I need to fix that. But the eval style comes about because it does an eval, right? It just does eval file.read drum file, right? And then it does that like every 4 measures, right? It could actually go faster, but I'm not sure how much faster. So I may make it faster later when I increase the speed. To increase the, the responsiveness of the instrument. But right now, waiting 4 beats for the change is not like a major loss. It's called Archaeopteryx, which is, the either the last dinosaur or the first bird, right? Which, obviously it's like a sci-fi thing, right? It's the end of the humans and the beginning of the happy robots that sing to us, or something, right? Let's see. A couple notes on design, actually, because the name Archaeopteryx also refers to some other strategies, right? Dance music is what this thing is built for. So in the late 80s, dance music kind of exploded as a form, especially in Europe. I'm from Chicago originally, which is kind of where it started, or at least a lot of it. And there was something kind of interesting where it was this sort of revolutionary thing where both revolutionary in that it was very entrepreneurial and revolutionary in that it was very much anarchist, right? And, very recently, I was under the impression that the entrepreneurial aspect was doing very well, but the anarchist element had died, right? Because there are now, big super clubs in London where you can go and it's, £100 to get in, and, they have like a special joint venture with PlayStation to set up brand new PlayStations that the clubbers can play with, and, that's great. But the anarchism was also, in my mind, a positive attribute, and it seems bad that it was lost. And then I went to Burning Man, where I discovered that it is not, in fact, lost. The sort of apex of the commercial side of dance music occurs yearly in Miami with a thing called the Winter Music Conference, which is kind of like a cross between a constant party and a trade show. It's very expensive. Burning Man happens in the summer, and it's kind of like the, where, you've got the Winter Music Conference and the Summer Chaos Festival. And there's a lot of very interesting engineering that happens there, actually. Some really strange things. Spider robots that you can drive around in. I'm not even kidding. There's 2 different versions of spider robots you can drive around in that I've seen. One is small, right, but very mobile. The other is gigantic and makes the earth shake and puts divots in the ground and always looks like it's about to fall over. Anyway, that's kind of a tangent. So let me tell you a little bit more about how this works, right? When I do the eval, right, what am I changing, right? This is what I was changing. I was changing these 2 lines that define number generator and next, right? And I would comment out this number generator and next, bring this one in, and vice versa, right? So these guys are lambdas, right? Actually, the first line of code in Archaeopteryx is alias capital L lambda, right? And the reason for that is it uses lambda so much that I wanted to kind of stop having it in there as a word and just turn it into an element of syntax. So, do you guys know about Lisp a little bit? Okay, so this is all about that Lispy thing, right? Where code is data and data is code, right? So the number generator, obviously, generates numbers from 0 to 1, right? They represent a measure of probability, right? Up here, you manually define a probability matrix for 16 beats for each drum, right? Which is to say, actually you define a line of probabilities for each drum for 16 beats. And the matrix comes about because there's 10 drums, 16 beats, right? So 10 rows and 16 columns, right? And obviously you can, use mathematical expressions to generate the lists rather than simply building them manually. And that's actually something I plan to do more in the future when I get some of the better features, lined up and I can, start to experiment. So what you do is you take a measure of probability and you filter it against the probability matrix to determine which drums will play, right? So that's why when you change this to a constant, you get the same pattern, right? Whereas if you put it on rand, you get a different pattern every time, right? The other thing I was changing is next, which will take a little explaining. Okay, so all that stuff I was just telling you about how it does the probability matrix, that happens inside drum, right? This is the file drum. What it does is it just defines the attributes, right? And it has a method called play, which does when on the beat, right? Now, you see this syntax all the time when @when is an array, right? This is actually shorthand for a lambda.call or a proc.call, right? So I'm passing in when, right, which takes a beat and returns false, right? And then play simply runs that lambda against a particular beat, right? And when does not stay that simple, right? Initially it's just take a beat and return false, right? But you change it by generating these probabilities, turning them into a lambda, right? And then throwing them in a queue, and then calling next on the queue. And next, these are all lambdas, actually. The traditional way of using object-oriented programming is to say I've got a class, right, and it has some methods, right? But if you store your methods in slots on the object, you can change them on the fly, right? So this is essentially, these are objects that, instead of you redefine it with like class bracket self or, some metaprogramming, this skips the whole metaprogramming thing by saying that an object is just a slot, or is just a thing which has slots that methods go in, right? And then instead of like redefining them and them being static, but now they're redefined, you just define them, you just throw them in there, right? So over the course of the music I was playing earlier, this probably generated, a large number of methods. I'm not sure exactly how many. I believe it calls generate every measure. Probably played like 50 to 100 measures, and there's 10 drums, so that would be like 500 to 1,000 methods, quote unquote, right? They're not actually methods, they're objects that, are very similar to methods. Are you all with me so far? Okay, good. So the other thing I was changing was next, right? I was commenting this one out and this one in, or vice versa, right? So next takes a queue and then returns some element from the queue, right? This one, if you'll, it takes a queue and then it just returns the last element of the queue. And I did this because I forgot about queue.last, right? You can just do array.last. That will produce the same result, but I forgot that method existed. So this one, there might even be a shorthand for this, right? But this takes a cue and returns something randomly selected from within the cue, right? Which is why sometimes the drums drop out, right? Because the bass drum and the snare are both set to a probability of 100% so that they always play, right? But if you randomly select from within the cue, sometimes you're going to select that when that takes a beat and returns false. So that enables you to have these things dropping out without changing the probability matrix. Let's see. I don't know. I think there should be, but I really don't know. I've actually seen it, but I think you have to like add it. I'm not sure. All right, so you would do, class array. No, but there should be. I think there should be, but there's not. Let's see. Any other questions? Go ahead. I think any language. What I'm actually doing is I got this from a book by Topher Sill called Practical Ruby Projects, and he uses Ruby DL to get to underlying C libraries. And I didn't actually include this in this package, but you can use it for Linux and Windows as well. He has different solutions for each platform. Right? There's a set of APIs on the Mac called Core MIDI. And I actually talked with him today via email, coincidentally enough, and I was asking him if you can do the same thing with MIDI in. And it turns out that MIDI in is a little more complicated because, at least on the Mac, the way that the API works for MIDI in is you have to give it a callback function that runs in a separate high priority thread, which, managing that in Ruby when it's stuff that's going to happen in C, it's like that. So I might have to learn C. But Ruby DL allows you to get to anything that runs on your machine in C, right? So you could also get to core image with it, for example, or core audio, or anything that you might have on your particular machine. So the mechanics is kind of cheating because the hard part was actually just, I found it in a book. I'll build all kinds of stuff on this. But that's actually a good thing, right? Because when you're building on top of that kind of foundation, right, and you're addressing a core, like a language that's used all over the place, this is also used in VJ software, right? Which means that when I get done with the musical part, at some point, I'll be able to add a video part, right? I mean, I got to buy the software, right, or find some open source or what have you, right? But I'm probably just going to buy this one called Archaeopteryx, right? But it also does the same thing. It receives MIDI that can go to a host of parameters, right? Bada bing, bada boom. And lighting systems run on MIDI as well. And there's actually a lot of hackers making robots that run on MIDI, although I don't know too much about that yet. Oof. Actually, I can give you an idea. Basically, it's a string of bytes, right? It looks more or less... okay, hold on. Like... hold on. It is. It's very minimal. It's just bytes. Because I had to find it for the, okay. So this is the stuff that we have from Topher, right? This is an on message. This is a controller ID, right? And yeah, they're, what is it, octal? I don't know. So it's a string of those, right? Like the on and the off is like an instruction, and then you have a controller ID and a value, or in the case of a note, you would have an instruction, a channel, and a value, right? And there's a couple other things too. So you get this. I think it's like 8 bytes, but I don't really know. So basically, I can't, but I have an idea. Roughly. The thing is, I actually first sort of hacked MIDI on the Korg M1, which was a sequencer / synthesizer in like the early 90s, late 80s. I think late 80s. When I was like a kid, I was like 15. So although I've never seen raw MIDI, I'm very familiar with the spec, right? There's actually there's stuff like OSC and like Max MSP and DSP. These are all these different ways of doing more with audio than I am doing in this system. But what I'm just doing is harnessing a existing, standard, and then, you can do anything with it, right? That's why the possibilities are so great, because people have already set up like the pathways, right? And all I'm doing is, in a sense, that infrastructure is like a core nervous system without a brain, right? So then you just add a brain, right? And like suddenly it's more interesting, right? So let's see what else is going on here. I guess that's it. But I want to tell you a little bit about the business end of this too. Because I've shown this to people and they've gone, oh, that's fun, And it's like nice, but I kind of want to slap them. Because it's like, oh, you're doing something for your own personal satisfaction. What do you do for a living? And it's like, there is money here, okay? Let me show you part of the presentation. Because I spent like half an hour on the code, but I just want to show you a little bit of like the presentation. There's a DJ called DJ Sasha, right? Who does laptop DJing with Ableton Live, right? And what he did is he hired a guy to build him a special mixer that is essentially it's like a case mod plus a MIDI instrument that houses an Ableton Live box. I've actually got pictures of it in here. Hold on one sec. So the thing is, that guy got paid by DJ Sasha, right? I haven't got anyone to pay me yet, but here's the thing. I actually got a personal email from Richie Houghton about this after I sort of alerted his record label to it. If you don't know, Richie Houghton is kind of a pioneer in these kinds of things. He's a superstar DJ in the world of techno, which means that he is not famous to many people, but the few people to whom he is famous, he's a freaking huge deal to them. Like he can walk through a crowd and like no one will know who he is, especially in this country, right? But when he walks through the crowd and gets to wherever he's going, there's this room full of people who consider him a god, right? And the long and the short of it is that a guy like that can come up with the money to pay one programmer to do some nifty shit, right? And he's not the only guy out there. There's a lot of people doing this stuff. So let me see if I can find these pictures. Actually, I'll just skip to the beginning, because this is like 100 pictures of people DJing with laptops, right? And, people at the party. right? And it sets the scene, right? These are people having a good time. This is a club that makes money, right? This is, there's a variety of DJs doing this, right? And if you pay attention to the hardware they're using, let's see if I can. Okay, here's a guy just using a mouse, right, or the trackpad. These guys have, you can't see it, but next to his shirt, there's a box. I think it's called the Evolution. Yeah, cool. That's one of the many MIDI controllers that exist, right? There's tons of these freaking things, and they all sell for like $500 a piece, right? That was a good transition. Yeah, so there is actually a business plan here, and I'm just going to summarize here, because the thing is, if you're really curious, you can Google me and the project, and I did a thing at Goruko where I, ranted about it and, went through the whole deal, and I'm going to do it again at the Ruby Hoedown, but it's going to be an improved version. So I didn't want to, just do the same thing that you can find on the web already, and that you'll be able to find at least one more version of, and probably two, right? Because there's probably going to be at least two, maybe even three more versions of this on the web, because I'm doing it at Ruby Hoedown and Ruby Nation, which, Ruby Hoedown will definitely have Confreaks videoing it, and they videoed me in Goruko in New York doing it. They might be videoing Ruby Nation, and I think they'll probably do it at Ruby Fringe as well. And I'm also supposed to give a presentation on building a Bayesian RSS aggregator at OSCON in like a week or two in Portland. But the project that I was supposed to talk about completely failed. And it failed basically because this one guy I work with was a total asshole, right? So I don't want to give a whole presentation about don't work with assholes. Because you know what? You don't need a whole presentation. It's a sentence, and it's not even a long sentence, right? So instead, I'm just going to hijack my own presentation and do Archaeopteryx instead, right? And that might get videoed too, right? So I'm not going to go through the whole spiel, but there's a business plan here, and it's actually based on, hold on. So this, R2D2 plus Aphex Twin, right? This is Aphex Twin's an experimental electronic musician. That's basically what I got with the Ruby continuations thing, like, right? Like, it's cool, but what can you do with it? Nothing, right? So that's just a, entertaining picture, and here's, attractive females who are, drawn by computers, right? Because, obviously, like, everyone in this room can understand the idea of saying, let's have a party, I'll bring my laptop, right? But you wouldn't think that's something that normal people out there in the big wide world could also say, right? But it's true, you can, right? Like, you don't even say, let's have a party, I'm going to bring my laptop, right? It's, let's have a party because this one dude is bringing his laptop, right? Which is kind of a new thing, right? It used to be just us that could understand that concept. Now it's not. So anyway, some of you may be familiar with this book, right? Hackers and Painters. Let me just take out the ARC reference to avoid the confusion. By Paul Graham, who said that a programmer is a kind of artist, right? If that's true, right, then what you should do is you should build stuff because you believe it should exist, right? Because you have like this idea, and it's like, wow, that's such a cool idea, I'm going to build it, right? And that's basically where this came from. Hold on one sec. Again, I'm going to skip a lot of the stuff that you can see anyway, and just get to the core of the idea. Hold on. Here's R2D2 wearing a sombrero. When in doubt, go for the sombrero. It always works. Okay, this guy, Jay Phillips. This, can I? Yeah, cool. Here he is skydiving, right? Looking all happy. So he recently blogged about how his career is adhesion. Adhesion is this thing he created while he was in college, right? It is a Rails-esque framework for voice over IP, right? And after a while, he spent some time doing what I'm doing, which is going to users groups and conferences and saying this thing is cool, right? And getting people to use it, right? And so they started using it, and it became a business for him, consulting on it, right? So what's interesting about that, right, is that there's a lot of venture capitalists who are actually very, very alarmed by internet startups because we use free software and commodity servers, right? So they're used to this model where they have to give us $20 million for us to start our own businesses, right? This is no longer the case, right? You can, you can launch a website for very, very small amounts of money. And it's very alarming to venture capitalists because they are used to controlling that process and profiting from it. They no longer control the process and they no longer make any money from it, right? There have been no IPOs in 2008, if I remember correctly. There were fewer in 2007 than in 2006. And they're worried about that stuff. But what's interesting about this is that Jay Phillips' career, right, it might not just be that internet startups are too cheap to fund for a venture capitalist, right? It might also be that an internet startup is too small for them even to see, right? Because Jay Phillips' career is an internet startup, right? He built something, put it on the internet, got users interested, and made money off the consulting, right? Got his own business off the ground, right? And he has not, had an IPO. You cannot buy shares in Jay Phillips, right? But he has made enough money with this that all he does is work on something he created, right? Which has got to be a very satisfying experience. And I talked to him, I met him at a couple conferences, and he's got a Mac Pro that's 8 core CPUs, 8 CPUs on the thing, or quad, 4 CPUs, I don't know what. But it just has ridiculous RAM. He'll be burning DVDs, compiling in Linux on a virtual machine, and playing Warcraft all at the same time without his machine even twitching at all. So you can understand from a distance, right? In theory, you can see why it might be nice to be in this situation. And if you get real practical details from his life, it turns out that it's true. So this idea, right, if there's, this money to be made by, dance music is a very big thing in other countries, right? It's kind of a big thing here in the big cities. It's huge in Europe, right? And if you get a European to hire you, they pay you with magical European money, right? Which is worth more, right? I don't know if you guys have been to Europe recently, right? But right now, you can bring $100 and buy a donut, right? That's it, So they pay you with this magical European currency that actually buys stuff, and it's kind of cool. So yeah, and this guy Sasha, from the allegations, the stories, he's rumored to make $25,000 a night. Now he probably makes less, but he may make more, right? If you're playing New Year's Eve and you're DJ Sasha, that particular night is probably more than $25,000, right? Because DJ Sasha brings people to the club sells drinks, the club sells tickets, da-da-da-da-da. That's a lot of money. And some of it goes to him because he has the draw, right? And some of it goes to the guy who built this thing for him. Sorry, go ahead. Well, what Richie Houghton needs that he doesn't have yet is MIDI in, which is why I probably have to learn C. What DJ Sasha, I don't know. He's got a pretty good system. In addition to these purpose-made bits of tech, he also has a staff of MP3 digitizers who get the records, that were sent to him by various people. They, burn them to MP3. They put them on a hard drive for him, and he, listens to them on the plane. Right. So probably not that much. Maybe an MP3 classification solution. He's probably working off the system that he devised in his head. He probably also needs version control for remixes. Because, I don't know if you've ever, worked in an office with graphic designers or musicians or people who work in film. They all do this ghetto version control where they, name it, this one has sparkles, right? And this one is number 4, right? And then they're, in too much of a hurry to type 5, so then they just go, 4-0, 4-1, or 400, or, bluebells, because they saw some bluebell flowers outside, So they have this version control solution which is very, very lame. And Time Machine is not going to be the answer for them. So, no, but, no, I know. And you know why, right? Because it's like, what is this arcane wizardry Unix thing, you know? Like, I went to in Hollywood, like in West LA, a film company, right? And they needed like some, you know, work done on their RAID array or something. So the first thing I did is I brought up the terminal. And they're like, you know, what's that? You're typing and it knows what you mean, you know? So, you know, the thing to do to sell them version control is to package it, you know, get a graphic designer to put a face on it that they can understand. Or Git, right? Or, you know, either one, right? Not Tortoise SVN though. No, because it's ugly. You got it. Oh, no. What you do is you put, see, this is a business plan that I'll probably never get to, so I'll just give it a, you know, go for it. Right? What you do is you build like a GUI to, you know, any decent source control system, right? And then you hand it off to a designer to make it useful, or you collaborate with a designer to understand how non-techies relate to the whole concept, right? And then just say, you know, we've got this thing that would be useful to people if they knew how to use it. Let's build a way for them to use it that makes sense to them. Because the typing is never going to get through their heads, right? But all the rest of it, the idea that you save versions as you go and you branch in different directions, that's something they already do, you know, just in a haphazard way. Some of them develop their own systems. Like I know a guy who works like in he's, you know, a mix engineer and producer, and he has this very detailed system of folders and subfolders, and, you know, I'll add numbers to the name under these circumstances, and the whole thing actually follows an algorithm that he made up, but which he performs by hand, right? So that's a different thing. That would be a great business plan. That's what DJ Sasha needs. But total tangent. It's like version control for creatives, right? Creatives. Uh-huh. That's exactly the thing, yeah. But also for audio and film. So, yeah, that sounds good. More questions? I can show you some. Oh, there's one thing that's kind of neat that I should show you. So this method go, which obviously I need like better method names. Or actually, the method name is okay, but this should be called loop. Actually, just imagine that this says loop. This method go is kind of interesting. What I first do is I define a lambda. This whole thing is a big lambda, right? And then here, I schedule the lambda, right? I say at a particular time, all this stuff here, everything after the at and before the generate beats is just determining the time, right? At a particular time, generate beats, right? So what it does is this method play is also unfortunately named. Because what it actually does is it doesn't play, it schedules, right? And this one, send controller message, also schedules. So these are both unfortunately named methods, right? This should be schedule controller message, and this should be schedule notes of beats, right? But this is generate beats. What it does is it schedules a whole bunch of beats in controller messages, and then the last line in that lambda is scheduling itself. So it's a recursive lambda, right? And the reason for that is because, you know, A, if you didn't do it, it would go forever. And B, if it's continually generating the beats, it actually overwhelms its ability to play the beats because it's, you know, it'll just create an infinite amount of data to play later. Evil timer offset, what the fuck? There's this evil timer offset problem, man. It's like, what the fuck? You know? I'm actually, okay, just total tangent. I'm a very big fan of informal variable names. Like, I was testing something, right? And I actually did this. This is actual code that I wrote at work yesterday. right? This was in a controller, right? In a Rails controller. And then in the view, I put, I can call a subclass or, an inner class from the view if Muppet balls fuzzy, right? And it worked, right? And the big win on this, right, is that other people work on this project, right? So if they come across some code and it says, that it's all about whether or not Muppet balls are fuzzy, right? They're going to know right away, the minute they look at it, they're going to be like, okay, this obviously is not code that Giles will be upset if I delete, And, this is given this name because I have to solve this problem. And, when I do, the code will look nicer, right? And I'll have that variable name out of there, and it'll all be happy and good. Let's see. Yeah. Make it stand out. Make it be like, class, fucked up class that I need to destroy, and call the method, oops, I can't believe I wrote this, Because then if you're sitting around and you're like, gosh, I really like this software, but there might be some more work I need to do on it. You'll go through and you'll be like, oh, I guess I didn't want to keep that, and there you go. All right. Testing is good too. Actually, that's the other reason that I have the logging output, right? Because I couldn't figure out how to test code that makes noise, right? And then I realized all I actually have to do is test that it, creates these MIDI messages. So most of that is created. It's still kind of messy, but I got to clean it up. Also it's partly that it was not so obvious how to test it, and partly that I just got out of the habit. I don't know. Like it's like working out. Like you feel better when you do it, but sometimes you get out of the habit anyway. So I just got to get back on the wagon. I think that's all I got. More questions? Go ahead. Oh, okay. Go ahead. Thanks. Yeah, it's on GitHub. I don't have the wireless. I don't know what to do with, but probably this one. No. It would understand. It would explain the stuff that allows you to send MIDI messages. Everything after that is me. And I've actually been kind of lax about documenting it. But if you feel comfortable using Lambda, it'll all make sense. And if not making sense of it will make you comfortable with Lambda. It's basically if you know how to use procs or lambdas, you're done. That's it. Boom. That's the whole thing. All it is doing Lispy stuff. Like even that idea that instead of defining methods, you just put lambdas in slots. That's just I actually got that idea from Lisp, but what it really is JavaScript, right? Because that's what you do with JavaScript. You just create a function, put it in a slot, right? Yeah, prototype, yeah. Well, but not prototype the package, prototype the model. Right. So, you can do that in Ruby with classes, but you can also just throw lambdas in after accesses. And, bada bing, bada boom. Yeah, because actually I got the idea from this book, and I'm going to go on anyway, because it's a question. There's a book called This Is Your Brain on Music, and it talks about how what you have in music is basically patterns of patterns of patterns, right? So I'm like, why not have something that generates patterns and modifies those patterns, right? And there's a package called Ruby to Ruby, which allows you to take a proc, and it has like a toString method, right? So any proc you can just turn back into a string, permutate the string, and eval it back into a proc, right? So you can take any running code and just, change whatever you want to change, right? You can even have a randomizer hooked up to a regular expression. If you've got if the code in your procs is sufficiently regular that a regular expression would actually detect patterns, you could just pull those patterns out.
That concludes this episode of the SD.RB podcast. See you next time.